Hello everyone. Today I want to talk about Node.js runtime. I'm gonna go over its components, how they are interacting with each other, and as I go through I will write piece of information to the R markdown. First thing is Node.js is not a language but a runtime which executes the JavaScript code inside. JavaScript itself is single thread, meaning it can only execute one task at a time on a single CPU core. However, Node.js is non-blocking. When Node.js encounters a time-consuming task, it will delegate to other thread pools, different than from main thread, and continue being responsive. I want to explain keep being responsive with an example. Imagine you have a web server, and what it does is it gets the data from database and returns to users. Only time-consuming part for this web server is reading the database. Other operations doesn't take time. And keep that in mind. Reading the database is slow operation. It will take time. And imagine there are two requests coming to your web server at the same time. What Node.js will do is it's gonna take the first request and run your resource handler. And when it encounters the time-consuming operation, which is reading the database, it will delegate that operation to other pools and not gonna wait for the response. It will continue answering the second request. And when it encounters the time-consuming part, reading the database, again, it will delegate the task to other thread pool. And of course, when database response is ready, it's gonna take it and return to the correct user. So that is what I mean by keep being responsive. And now we are gonna explain the parts that achieve this. Let's look at our diagram. In outermost, we have Node.js runtime, and we have two components: V8 JavaScript engine developed by Chrome and Libo, and they have their own components inside them. Heap and call stack belongs to V8 engine. Event loop, event queue, thread pool belongs to Libo library. And we have Node.js bindings for these two components to talk with each other. First component is call stack. One is call stack. Responsibility of the call stack is keep tracking of the function calls in the main thread. When a function call is occurred in your code in main thread, it will be added into call stack for execution. If this green bar represents a function call. If this function calls another function inside its body, it will be added on top of it. And same thing can happen. If second function has a function call in its body, that function call will be added on top of it. And it will keep doing that. Its structure is last in, first out structure. Without last function call removed from call stack, previous function calls will remain in the call stack. We have heap. Heap is the place where you store your objects and other types in the memory. And it's managed by garbage collector, which automatically frees up the memory when that objects are not being used anymore. And third, we have event queue. Event queue is the place where callback functions are put when time-consuming operations are finished. It is the place where callback functions are placed when time-consuming operations are finished. Then we have event loop. Event loop is a mechanism that constantly checks both event queue and call stack. If call stack is empty, meaning main thread doesn't do anything at the moment, it will take the callback from event queue and place it on the call stack. this is its job. It will take the callback from event queue and place it in the call stack for execution, of course. Then what we have is thread pool. It is the place where time consuming tasks are placed. So what are the time consuming task examples? One is making HTTP request, or using set timeout, or using read file from core FS module. All of those are handled by other thread pools. Let's use our previous example to identify how async operation goes through these components. We said we have a web server that returns user data. I'm gonna copy paste some basic code in here, and this will be our resource handler. When Node.js receives the request, it will put this resource handler into call stack, which is a function. Okay, and in that call stack, it will start, JavaScript engine will start to execute code line by line from top to bottom, and it will encounter the read database operation, which is async operation. It takes time, and it will directly delegate this operation to thread pool, and it will continue executing synchronous code if there is any in your function body. And when it's finished logging this part, your get user data function will be removed from the call stack, and call stack is empty and answer other user requests. Okay, but in meantime, thread pool is doing its responsibility, getting data from database. When it's done, it will put this callback, this is the callback, it will put this callback into event queue. Callback will wait in the event queue until event loop takes it and put it into call stack, which will only occur if call stack is empty. And if it's empty, console log will execute it in the main thread. So output will be like this. First you will see other synchronous operations log, and then you see user data after a time span is passed. This is all that I want to talk about right now. Maybe in the future I can talk about wait statement promise system in Node.js. It behaves a little bit differently from callback, because if you put wait statement in your function, it will not be removed from the call stack, but it will be suspended and kept in the heap to be executed later when async operation is completed. I may talk more about call stack because browser has a good UI to showcase how call stack is changing. Is it seen right here? Yeah. Browser has good UI to see what's going on in the call stack. There may be a video about showcasing state changes in the call stack. But for today, this is all I want to talk about. Thank you for your time.